Let's talk about polyhedra. What are polyhedra? Well, if we focus on that word polyhedrons, poly is Greek for many, hedron means Greek for face, so polyhedron means many faces. Names for two-dimensional shapes and three-dimensional shapes can be confusing since the beginnings of them are similar. For example, a dodecagon is a two-dimensional 12-sided shape, as you see in this figure right here. Whereas a dodecahedron is a three-dimensional 12-sided regular pentagon. Platonic solids, or specific polyhedrons. So Plato was a Greek philosopher and mathematician. He worked out that some polyhedron are identical in shape and size, where the edges are the same length, the angles are the same size, and the vertices are identical. Only 5 of these exist. A tetrahedron, which some might, if you're identifying it, might call a triangular pyramid. A cube, which you might call a regular rectangular prism. An octahedron, an icosahedron, and a dodecahedron. So those are the 5 Platonic solids. How about prisms? Prisms, remember, are identified by having 2 identical parallel faces that are joined by rectangles. Here's some examples of prisms. Remember, prisms are named by their base, no matter how they're oriented. So this is a triangular prism. This is a cube, which could also be considered a rectangular prism, because all squares are rectangles. This is a pentagonal prism because the bases are pentagons. This is a hexagonal prism. This is an octagonal prism. And this is a decagonal prism. Okay, so you can name those prisms. Remember, here's an example of prisms and not prisms. So you can see the ones on the left all have what we described, whereas the ones on the right do not. We have several pyramids on the right, we have a sphere, we have a cone, we have a cylinder, and then we have some truncated prisms. Okay, so make sure you can identify the difference between prisms and not prisms. Here's some examples of what students might say. The statements to the right are definitions or explanations that elementary students have given for prisms. In each case, some of the information is correct and some is incorrect. What is accurate in these statements and what needs clarification? This is a great activity in justifying your answers. So a prism is like a square, it's made up of flat sides. Prisms and pyramids both have faces, edges, and vertices, so they're the same thing. A prism has 2 bases, it's just like a can. And a prism is a 3D figure that has triangles. So as you were dissecting those statements, these are some answers you may have come up with. A prism is like a square, it's made up of flat sides. Well, a prism is made up of flat sides. That part is true. However, a square is 2-dimensional and a prism is 3-dimensional. So the student was partially correct. Statement number 2, prisms and pyramids both have faces, edges, and vertices, so they're the same thing. Well, prisms and pyramids do both have faces, edges, and vertices. However, prisms have 2 identical parallel faces with rectangular lateral faces, and pyramids have 1 base and triangular lateral faces. A prism has 2 bases, it's just like a can. Well, a prism does have 2 bases, but it's different than a can since there's no curved edges in a prism. A prism is a 3D figure that has triangles. Well, a prism is a 3D figure, but it does not have to contain triangles. It has rectangular lateral faces. So sometimes part of the student's reasoning is accurate and another part is not accurate. I hope this helped you see what polyhedron are as well as prisms. Thanks for watching.